Uh, Hi students, today we are going to discuss the week 6 assignment. The first question they are asking is that we need to calculate the Pearson coefficient for the given data. They have given the xy values. We need to calculate the Pearson correlation coefficient. The formula for calculating the Pearson correlation coefficient is this one. So here R equals to sigma into xi minus x bar into yi minus y bar divided by square root of sigma of, that is sigma is nothing but summation, you can just say summation of xi minus x bar whole square into summation of y by minus y bar whole square. It's not okay. So first of all, what do I need to do here is, first of all, from the given data, you have x and y values. So x values, how many samples they have given? 5 samples. So n is 5. And as you see here, r is nothing but correlation coefficient. Xi is nothing but values of x variable in a sample. So xi will be this one. X0, x1, x2, x3, x4, so on like that. If you have considered this as x1, so x1 to x5 values. X bar is nothing but mean of the values of x variable. So how can I calculate the mean? The mean formula will be x bar. Suppose if you consider this as x dash or something, I'm writing, I can't say x bar. That's why let's say x bar or x dash equals to, or else I'll just say mean of x equals to xi summation of xi. Okay, summation of xi with all the values divided by n number of samples. Okay, so what do I need to do here? I need to calculate the sum. 4.5 plus 4.2 plus 3.21 plus 2.1 plus 9.8 divided by 5. Okay, this will be my mean. Okay, that mean is nothing but x bar. Okay, you need to find out x bar like that. Similarly, you will also find x bar, y, I mean mean of y. So mean of y will be summation of all the values of y, okay, divided by n. So here it will be now 2.3 plus 2.1 plus 1.5 plus 1.0 plus 6. 6.8, sorry, 6.8 divided by 5, because those are nothing but number of samples. Okay, so that will be your y bar. Once you got the x bar and y bar, now what do you need to do? You need to calculate these values. You have to find the mean of x bar and y bar, and you have to subtract this mean from the samples. Okay, so it will be, the first value will be 4.5 minus the mean. Okay, similarly the second value will be 4.2 minus mean, 3.21 minus mean, like that. Okay, so I'll just show you, there is one online link where you can give this all these x values and you can find how it works. So I'm giving those values 4.5, 4.2. But in exam, you need to do the calculation, guys. Here, just for shortcut, I'm just showing you. I already explained how can you calculate the mean. So applying that in the formula, that these values in this formula, you need to solve this Pearson correlation coefficient. Okay. So here 2.1 and 9.8. So we got 5 values. Let's give y values also. 2.3, 2.1, 1.5, 1.0 and 6.8. Okay. Now I'm going to compute these values, calculate R. We'll get the value as 0.9947. This will be your final result. Whenever you substitute these values, once you calculated these values, you just need to substitute. Then you'll be getting this value as the answer. Okay. So let's see how did they do it. So this is the same formula. So here mx is nothing but mean of x. So once you got this value, that will be equals to 4.762. You can also calculate these values mean. Just do the calculation. So mean of y will be 2.740. Okay, this will be your mean of y. Okay, now what did I do it? If they have done here x minus mx, okay, so xi is nothing but 4.5. 4.5 minus 4.762 will give you this result, 0.262. Like that, they have calculated all the values. I mean, they have done this particular formula for all the five values. Similarly, you have to do for these values also. Once you have done, you have to do it x bar minus, just multiply this x bar minus x, sorry, x1 minus x bar into y1 minus yi minus y bar. Okay, multiply these two and take a summation. Later again you have to find xi minus x bar whole square. Once do that and take the summation. Again do the square of yi minus y bar whole square and do the summation. Then you have to substitute those values here. Okay, that is what they have done here. They have taken the square root, or square of these values. Okay, after that they have multiplied this, and this, then after that you have to find the summation of these values, right? They have found the summation of this one. Once you have found the summation, you'll be getting these values. Okay, and this summation of this product is also necessary according to this formula. That's why you got these values. You just need to substitute them here. Okay. Here you can find what are the values. So sigma of this one is 23.81 divided by 5 will giving us mean of x. Okay. Similarly for y values also you got the sigma, you are getting the mean. Then next n equals to 5. They have done the product and they have taken the summation. Now they're just they're just substituting the values here. So you'll be getting the R value as 0.9947. Okay. So in this way, you can calculate the Pearson coefficient. You also calculate the Pearson coefficient in R Studio using one formula. That is whenever you know the dependent variable and independent variable, between which variables you want to calculate the Pearson correlation coefficient, you can apply the formula. There is one command. According to that command, you can do it. But here, they didn't give us any command here. They just gave us the values. So from the values, how can you calculate the Pearson coefficient is, one thing you have to remember, that you have to calculate the mean of x value, mean of x and mean of y, and using this formula, you can calculate the Pearson coefficient. Once you calculate the mean, you have to subtract the mean from all the values of x. You should subtract the mean of x from all the values of x, all the samples of x. Similarly, you have to subtract the mean of y from all the samples of y. Okay, after that, you will just do the multiplication of this one, x bar minus xi minus x bar into y bar, yi minus y bar, and you'll calculate the whole sum. That is the summation of this divided by summation of xi minus x bar whole square. First, you will also do the squares. In this way, you will be doing. I'm just repeating it so that you don't get confused. Okay. You will take the square of this one. Okay. And next you will multiply and all summations will be calculated, and that particular thing will be applied in this formula. That's it. Okay. Xx is nothing but summation of the squares. Okay. That is what. So because of this, we got the result as 0.99. 0.9947. Okay. And it's a positive sign. That is what you have to remember. Fine. Let's go to the second one. So they are saying they gave us a rating Y provided for each laptop based on the battery life X in years. So here, this is nothing but similar to the formula in this way. Y equals to beta naught plus beta 1x plus error. So here, this is nothing but This is called as slope. 0.5 is called as slope. This will be called as intercept. Okay. So they're asking what does this 1.98 represents? So we already know the equation for the linear regression is in the videos you can check this. Sorry, actually you have one type a plus bx or something. That there you will be calling this as a as slope. One moment, I will just show you. In videos you can check guys for these answers. I'll just show where it will become. So here if you say take this expression here. So linear model between yi and xy will be considered as yi equals to b naught plus b1 x bar plus ei. Ei is nothing but an error, b1 is nothing but the slope, and b naught is nothing but the intercept. Okay, this is the equation I was talking about. So here in our when we are comparing this particular equation with the data present here, so what did we get? We are comparing 1.98 plus 0.5x plus EI. EI is not given here, so there is no error. 1.98 will be representing the intercept. That is what you have to remember. Okay. So anything with x will be considered as slope. Okay. Anything beside x. And here homoscedasticity in regression analysis condition, homo is nothing but the error variance will always remain the same. If it is hetero, that is nothing but difference, then you have to say it's not uniform. Okay, that is what you have to remember. As it is homos, here it will be considered the error variance remains the same. It's theory part. So for the best linear regression, R square value should be equal to 0. So whenever you're having the R square value equal to 0 or approximately similar to 0, equal to 1 or say near to 1, then I can say that is the best linear model or good model. Okay, remember that. So R square value should always be equal to 1. Then I can say it's the best linear regression model. Okay. And coming to the fifth question. So here they have given us this particular summary and they're asking us based on this image, a model was built with an objective to predict the salary of an individual based on the years of experience. From the given output, what does the p-value indicate with respect to hypothesis testing? So, whenever there are whenever this value is written something like this, 8.67, 8.672 72e minus 0.9. So, what does it mean is it is nothing but 8.672 into 10 power minus 0.2. Then you can write it in this way. Sorry, this is not clear. Somewhere I have checked it. So if they have written in exponential, how can you convert that into the decimal point we are saying now? So in this way, you can write what are the decimal they have written into 10 power minus 5. That will be equals to the this one. In this way, you can. E power minus 5 is nothing but that whole part into 10 power minus 5. So here our value is nothing but 8.672 E minus 0.09, right? So this will be equals to, so I'm talking about this one. Fifth question. So they gave us the value is 8.672 in E minus 0.9, right? So this will be equals to 8.672 into 10 power 10 power minus 9. Okay. So obviously this value will be always lesser than 1. Okay. This value will always be lesser than 1. So whenever it is lesser than 1, it means that we need to reject the null hypothesis. Okay. If it is not, whenever the p-value is not lesser than 1, then you cannot reject the null hypothesis. But here you got a p-value. So once you calculate this value will definitely be lower than the 1. So I can definitely reject the null hypothesis, right? So whenever you're rejecting the null hypothesis, it means that what does the meaning of null hypothesis is nothing but the meaning of null hypothesis is there is no relation between what are variables, the dependent variables and independent variables. But here we are rejecting the null hypothesis. It means that there is definitely the relation between salary and years of experience. So from this image, you can conclude that thing. Okay, that is what you have to remember. Fine. Now here they have given us one what data set. From the data set, you have two values, MPG and weight. Okay. From that, what do I need to do? I need to calculate the adjusted R square. Okay. Next, I need to calculate the third quartile residual value. Next, T value corresponding to the coefficient of weight. Okay. So let me do that. So how can I do? How can I downloaded this data set already? So I'll just show you. So auto.csv is my data set. So this is my data set which is having MPG and weight. Now I need to read this data set into my RStudio and then I need to calculate the adjusted R square, third quartile residual value and T value corresponding to the coefficient of weight. So how do we do that? So first of all, to do that, what I'm going to do is I'm just checking which particular directory I am by going to File, Change Directory, and my data set is in download. So I'm going to downloads and clicking OK. So the command to read the data set is I want to read the data set and store it in some variable that is data, or else you can call it as auto. So into auto I'm storing this one, right? So I need to say like this, auto read.csv. Read.csv is the command which we will be using for reading the data. And now here I need to say which particular data file I need to read. The data set I want to read it. Okay. As I am in the directory, the change direct, whenever I went to change directory and I'm in downloads folder only. So I'm reading in this way, read.csv of which particular data set I need to read. So the data set I need to read is nothing but auto.csv, right? Now the data set has been read. So we'll just do auto. Once you have done the auto, you can see what all the values are there. Now the data set is read into auto. Now what will I do? I need to construct an linear model so that from whenever I do the summary of the linear model, I need to get the adjusted R square values and also third quartile value. 3Q is nothing but third quartile value. And next is the t value corresponding to the coefficients of weight. So depending on the coefficient, whatever you're getting, here you have different coefficients, right? Like that you need to get it. Okay. So now let's do that. So now I need to construct a linear model. So how can I construct a linear model? The command will be lm. So I am going to store this linear model inside auto mod lm. So lm will take two arguments. One is the formula, other is the data set what you want to refer to. Here formula is nothing but what they are predicting actually. They are trying to predict the salary based on the years of experience. So the salary is getting predicted based on the years of experience, right? So here they want to predict MPG using weight. The same thing here. So it will be predict MPG on based on weight. So here I will just write it as MPG similar to weight, comma, data equals to. Now what is a data set? The data set name we have given is auto, right? It is auto. So I'm going to use the same name here. So equals to auto. Sorry, I don't need to give this, I think. Okay. Now let's do the summary of auto mod. Now linear model got created. Now you can see here, this is the formula. This is the third quartile, 1.7341. Let's check whether we have those values here or not. Yes, third quartile residual is 1.73. Next is adjusted R square value. The adjusted R square value is 0.7706. Let's check. Yes, it's there, 0.77. Next, the t value corresponding to the coefficient of weight. Let's go to the coefficient of weight. This is the coefficient of weight. The t value here is nothing but minus 31.75. So that is the output. So in this way you have to do. What did we do? We first read the data set by using this command, that is read.csv of whatever data set file you want to read into auto is stored. Then I just displayed for you to see. Later again, what did I do here? I created a linear model MPG similar to this is the formula. We are going to predict this one based on the weight. Okay. And data equals to auto. This is nothing but auto's MPG column and auto's weight you are taking in consideration and you're constructing a linear model. So once I have constructed the linear model, I'm just doing the summary of this one. So I'm storing it in a linear model in one reference and I'm doing summary of that reference. Then you'll be getting this thing. Okay. So this is the third this third quartile adjusted R square and here you can see the t value of the weight will be this. Okay, like that you can do it. Okay, so this is we are done with the week 6 assignment, guys. Any doubts can ask me. Thank you.